Here we have a problem on ratio. Okay, let's go the information. If P to Q is a subduplicate ratio of P negative x square to Q negative x square, then x square is. Okay, using the given information, we have to solve for x square. Okay, now let me consider this particular statement over here. There is a P to Q. Let me write it over here, P to Q. And for this word is, we can write equal to, and subduplicate ratio of P negative x square to Q negative x square. So that is, we have to take a subduplicate ratio of this one. So how do we have to get a subduplicate of a particular ratio? Whenever I want to get subduplicate of a particular ratio, I have to take square root of for both the first term and second term. Okay, let me do it. That is square root of P negative x square to square root of Q negative x square. So this is a subduplicate ratio of this one, P negative x square to Q negative x square. Okay, here I have written the statement as an equation. I have taken the first ratio as it is, for is I have written equal to, and so I have written subduplicate ratio of this one over here by taking square root for the first term and second term. Okay, now to solve for x square, better we can write each ratio, I mean the ratio on the left side, the ratio on the right side as fraction. So then I'm getting P over Q on the left side. On the right side, we have square root of P negative x square divided by square root of Q negative x square. Okay, so here P over Q equals to, on the right side we have square root of for numerator and denominator. Whenever we have radical for both numerator and denominator of a fraction, we can write the radical, that is square root in common, that is square root of P negative x square divided by Q negative x square. Okay, now to solve for x square, I have to get up the square root we have on the left side, right side over here, sorry. So to get up the square root, I just square both sides of this equation. Let me do it. So let me square the stuff on the left side. When I square both sides of this equation, the square root over here and square will cancel out. And here we have this exponent 2 in common for the fraction. Whenever we have a common exponent for a fraction, the exponent can be distributed to the numerator and denominator. When I do so, I'm getting P square divided by Q square. On the right side, we have P negative x square divided by Q negative x square. Okay, now what we can do is we can do cross multiplication. That is, the numerator over here has to be multiplied by this denominator, and this numerator has to be multiplied by this denominator. When I do so, I'm getting P square times Q negative x square. On the right side, when I multiply this P negative x square by this Q square, I'm getting Q square times P negative x square. Just a moment, let me erase a circle. Okay, now let me continue over here. Okay, now let me distribute this P square to this Q and P square to this negative x square. When I do so, I am getting P square times Q negative P square x square. On the right side, I have to distribute this Q square to this P and Q square to this negative x square. So then I'm getting Q square P negative Q square x square. Okay, now to solve for x square, what I have to do is I have to get the terms which contain x square on one side of the equation, and I have to get the terms which do not contain x square on the other side of the equation. Okay, here this term contains x square and this term contains x square, but one is on the left side and other one is on the right side. Okay, to get the terms which contain x square on the same side of the equation, better we can get rid of this negative Q square x square on the right side. For that, we have to add Q square x square to both sides of the equation. Let me do it. Okay, so when I do so, this negative Q square x square, a positive Q square x square will cancel out. Then the resulting equation is a P square Q negative P square x square positive Q square x square equals to Q square P. Okay, here we got the terms which contain x square on the left side of the equation, but there is a term over here on the left side which does not contain x square. So we have to get rid of this. So for that, we have to subtract P square Q from both sides. Let me do it. So when I subtract P square cube from both sides, so this one will cancel, the positive value, negative value. And also in these two terms, we can write the term which contains positive sign at first, and I'm getting Q square times x square. Then we can write this one negative P square times x square. On the right side, we have Q square P negative P square Q. Now we can factor x square out from the expression on the left side over here, because both the terms contain x square. When I factor x square out, I have left Q square in the first term. Let me write over here, and negative P square in the second term. Let me write over here. And also, what is the greatest common divisor for the two terms over here? So that can be factored out. I think Q times P is the greatest common divisor for these two terms. So we can factor that out. Okay, if Q times P is factored out, I have Q left in the first term, and negative p left in the second term. And we can verify this factoring. That is, if I distribute this qp to this q, I'm getting q square p. When I distribute this qp to this negative p, I'm getting negative p square q. Okay, now to solve for x square, I have to get rid of this expression q square negative p square. For that, we have to divide both sides by q square negative p square. Let me do it, q square negative p square. So this q square negative p square and q square negative p square will cancel out. I'm getting x square equals to qp, and this qp can also be written as pq times q negative p. And now let me consider the algebraic identity, that is a square negative b square. Actually, it is called as difference of two squares. Whenever we have difference of two squares, it can be written in the factor form, that is a positive b times a negative b. This is one of the basic and important identities in algebra. Here we can use this identity over here in this q square negative p square to get the factor form of this one. So comparing this and this, I have q at the place of a over here and p at the place of b over here. So in this factor form, at the place of a we have to write q, at the place of b we have to write p, the same thing over here. Okay, let me do it. Then I'm getting q positive p times, let me write it, q negative p, that is a positive b times a negative b. Okay, here this q negative p will cancel out. Then I'm getting x square equals to pq divided by this q positive p can be written as a p positive q. Okay, I have solved for x square equals to pq over p positive q. I find this pq over p positive q exactly in answer choice C. So the correct answer choice for this question is C.